Welcome to the unit on sequences and series, review exercises. The objectives for this session are to review previous topics through exercises, namely, use logarithms to solve for x, and find the next values in a sequence of numbers. Pause the video and have a go at these review exercises. When you are ready to view the solutions, press play. Before we begin with the first exercise, let's remind ourselves of some theory. Exponential functions are functions of the form f of x equals a to the power x, where a is a constant. The inverses of exponential functions are called logarithms. So the exponential relationship with a not equal to 1 is a to the power x equals n. This can be written in terms of a logarithm as log n base a equals x. Let's now remind ourselves of some important laws and derivations in order to help us with the first exercise. So here's the multiplication law and the division law and the power law. And here are some other important results or derivations that may help us with the first exercise. Using logarithms and your calculator, you can solve equations such as a to the power x equals b. Now let's take a look at the first exercise. We are required to solve the equations shown on the screen, giving our answers to 3 decimal places. So let's have a go at the first part. We are required to solve 7 to the power x equals 89. Let's solve this. We've now colour-coded this equation in order to plug in the correct values into the logarithmic equation. So 7 to the power x equals 89 implies that log 89 base 7 equals x. Using the log function on your calculator will give you x equals 2.307 to 3 decimal places. You can check that this is correct by plugging in 7 to the power 2.307 and finding that it will give you approximately 89. And now for part B. We are required to solve 3 to the power 8x minus 3 equals 63. So let's solve this. Again, we're going to colour code, as shown on your screen, to give us that log 63 base 3 equals 8x minus 3, as shown. Again, using the log button, we'll give 8x minus 3 equals 3.771. We can check that 3 to the power 3.771 is approximately 63 on our calculator. And hence, if we rearrange the equation, we obtain 8x equals 6.771. We've simply added 3 to both sides. And so we have that x equals 6.771 over 8, which is 0.846 to 3 decimal places. And now for the next exercise. We are required to write the next 3 terms of each of the sequences shown on your screen. So let's have a go at part A first. Write the next 3 terms of 3, 7, 11, 15. Let's see if we can spot a pattern. The first thing we might consider is what's the difference between each of the values. So what's the jump between 3 and 7? Clearly it's 4. The difference between 11 and 7 is also 4. and the difference between 15 and 11. So we should expect that the next three terms have 4 added on to them each time. So after 15 we have, once we've added 4, 19. And then adding 4 again, we have 23. And finally for the third term, adding 4 again, we have 27. And now for part B. We are required to write the next three terms of 27, 22, 17 and 12. Again, let's find the difference between each of these terms, or each consecutive term. So the difference between 27 and 22 is 5, but we've gone down by 5, so we subtract 5. Similarly, subtracting 5 again gives us 17, and subtracting again gives us 12. So we've got the pattern. Let's subtract again to give us the next term, which is 7. Minus 5 is 2, and minus 5 again for the third term is minus 3. And now for part C. We are required to write the next three terms of minus 23, minus 20, minus 17 and minus 14. Again, if we find the difference, we've added 3 this time to minus 23 to obtain minus 20. Adding 3 again gives us minus 17, and adding 3 again gives us minus 14. So we can imagine that the sequence will continue in this way. So, in order to get the next three terms, let's add 3 each time. Add 3 to minus 14 gives us minus 11. Add 3 again gives us minus 8. And finally adding 3 again gives us minus 5. And now for part D. We are required to write the next three terms of 3, 5, 9 and 15. Now if we look at this sequence, we can see that the difference between 3 and 5 is 2, and the difference between 5 and 9 is 4, and the difference between 15 and 9 is 6. So we've added 2, then added 4, then added 6, and hopefully you can now spot a pattern. We seem to be going up in 2s in terms of addition. So 2, 4, 6, and therefore for the next three terms we're going to first add 8, then add 10, then add 12. So let's do that. So adding 8 to 15 gives us 23, adding 10 to 23 gives us 33, and finally adding 12 to 33 gives us 45. And now for part E. We are required to write the next three terms of 2, 4, 8, 16. You may perhaps be able to spot the pattern immediately. This time we're not adding, we're multiplying. So each time we're multiplying by 2. So 2 times 2 is 4. 2 times 4 is 8. 2 times 8 is 16. And then 2 times 16 is 32. 2 times 32 is 64. And finally for the third term, 2 times 64 is 128. And now for part F. We are required to write the next three terms of a third, a ninth, a 27th, and 1 over 81. You may have immediately been able to spot that the denominator seems to be multiplied by 3 each time. So we start with 3, and then we have 3 squared, which is 9, and then 3 cubed, which is 27, and then 3 to the power 4, which is 81. So in effect, we're multiplying each fraction by a third. So a third times a third is a ninth. A third times a ninth is 1 over 27. And 1 over 27 times a third is 1 over 81. So multiplying by a third again will give us 1 over 243. And multiplying by a third again will give us 1 over 729. And multiplying by a third again will give us 1 over 2187. This brings us to the end of this session. If you have understood its contents, you should be able to use logarithms to solve for x and find the next values in a sequence of numbers. Thank you very much for listening.